Geotechnical engineering, part A, soil mechanics. We want to calculate equivalent hydraulic conductivity in stratified soil. As an example of permeability, stratified soil consisting of H1, H2, and H3 layers. So if we have a soil consists of these three layers of H1, H2, H3 with 2 meters, 3 meters, and 4 meters of height, and K1 is equal to this amount in centimeter per second, K2 and K3 are provided. We want to estimate the ratio of equivalent hydraulic conductivity in terms of KH equivalent over K vertical equivalent. So we want to have the ratio of horizontal conductivity to vertical conductivity. Let's see how we can approach the problem. First, in horizontal fluid direction condition, KH equivalent horizontal hydraulic conductivity equivalent is equal to 1 over the total layers times K1 H1 plus K2 H2 over, so that's a 2 meters plus 3 plus 4, that's 5, 4, 1 over 9 meters times height of first layer, 0.2 meters, times the conductivity of the first layer, and just assume K1 is the conductivity in both directions. So that's either of Kx and Ky for all the soils. K2 remains the equal at both directions. And then the second layers, which is 3 meters times K2 plus 4.1 times 10 to negative 5 times 4, which is the height of H3, that turns to 107.07 10 to negative 4 centimeter per second, and it just gives us this amount of K horizontal equivalent 107.07 10 to negative 4 centimeter per second. And let's see what if the direction of flow is vertical. So with the based off previous calculation of, we know K vertical equivalent is equal to total height, which is again 9 meters, over H1, which is 2 meters, over K1, which is provided. And if you just replace the numeric value, it just gives you 9 over 2 times 10 to negative 4, 3 over 3.2 10 to negative 2, 4 over 4.1 to 10 negative 5. And if you do the math, it just gives you K vertical equivalent of 0.765 times 10 negative 4 centimeters. And the ratio of them, we want to know what is the KH equivalent ratio to K vertical equivalent ratio. Just subtract these two numbers, can get KH is equal to 139.96. Thank you. That was the story of the hydraulic conductivity in horizontal fluid direction, vertical fluid direction, and a sample calculation of how to do that. Thank you. See you on next videos.